Hi everyone, David Maley here. Today I'm going to show you something really cool. This is creating maps in R, but what we're going to be doing is we're going to be creating geomaps based on Google Maps. And as you can see down here in the bottom corner, it's going to be by two variables. So I'm going to show you how to do it with sales and transactions. And the reason why you want to do this is you can pull insights from this. You can have areas with the same color striation for sales that there's a size differentiation based on transactions. So for instance, this little dot right here, has the same level of sales as this one, but the transactions are much lower. So this one is getting more sales dollars per transaction than this one. So you can get some more insights and figure out different things based on your data. So what I want to do is I want to start off at the top. I want to walk you through step by step. These are really cool graphs, and you don't have to just pick the United States. You could pick anywhere in the world. I'm going to put other videos on here showing you how to do it in India and various other areas. You just have to have data that has state and city and country. Okay, if you have those three things, you can go and filter it down to what you want and show exactly how you want it to show. So what we're going to start off with first is, if you don't have ggmap, go and install that package, and right up here is the code for installing that package. Next, I'm bringing in ggmap, tidyverse, and dplyr. So I'm going to bring those three in. That's how you bring them in. If you don't have one of these, you don't have tidyverse, do the same thing. Install packages, tidyverse, or dplyr, or whatever. Okay. Next, I'm bringing in this other one for ReadXL. Now ReadXL, as I've said in the past videos, is a little bit different. It gets to be a little anal. So you want to, or picky, so you want to show it the exact location of where it is. This code right here will show it, and it'll find it. You'll never have a problem. Versus if you just do ReadXL, sometimes they'll say it can't find it, can't find the location, it gets lost somehow. And usually what happens is in a Windows update, it loses it. Next, I'm reading in my data set here. So let me move this over so you can see it's a little bit better here. Let's move this over so you can see the whole entirety of our code here. Okay, I'm gonna make that map really small and weird looking there for a minute. But what we're doing, is right here I'm reading in this Excel sheet with readXLSX, which is under this readXL. It's a function of it that's going to read in this, and it needs the exact location of it. This sheet right here, called furniture sales, will give me in map data. I'll show it to you right here. I can click here or I can click here, it doesn't matter. This is RStudio, so you can see it right here. It gives me country, province or state, and city. Okay, the rest of this we're not going to need yet, but we will eventually use the sales and transactions. But it's got this in it. So let's go back here. So this pulls it into map data. Next, what I'm doing is I'm saying I don't want the whole entire world's data. For this, I'm just looking at the East Coast and maybe a little bit of Texas or Mississippi and Illinois and Chicago and up to Vermont and Florida and even Havana. So I could show the whole world's data, but I'm going to tell you, when you build the geomap locations down below, it's going to take you quite a bit of time. It's going to take you probably a good 20 minutes to get all that data in for this data set. There's over 2,100 points in it. So what I want to do is I'm going to filter it. So right here you can see I am filtering this data set to just USA. So when you look back at map data, you have to make it the exact name that's under that country listing. Like, so in this, it's USA, and I'm only going to show what's USA. So but it's Albania, it's Brazil, it's Antarctica, it's not going to show. Okay, I'm just filtering it down to USA. You could filter down to any country you want. I'm just, in this case, filtering it to the USA. Next, what I'm doing is I'm building a data frame where I want to have both the city and the state fields in one field. So the field is going to be called location, and the data frame is right here. It's called dataframe.mapLocations, df.mapLocations, and it's a tibble. So doing that is going to put them both in that field. Next, I'm doing this where I'm going to get the geolocation data for each location in the map data and place them in a separate data frame called geo.mapLocations. So this is using the function geocode to go and get longitude and latitude and stuff like that. Next, now that I have it, I've got two different data frames, right? No, I need to have them the same one. Well, I need to have the data the longitude and latitude data from this one in this one. So what I've done here is I'm combining the data. So I'm combining, you can see right here, I'm c-binding dfmap locations and geomap locations. So it's a columnar bind, so I'm binding based on columns, not rows. So rows would be an appending. I'm not really doing that. I'm adding the columns from one to the other. So now dfmap locations, if I were to look at it, will have the longitude and latitude in it. Next, what I want to do is I want to create, because I don't just want to plot points based on cities. That's useless. I mean, okay, great. I got a map. I know where Charlotte is. I know where Philadelphia is, but that doesn't give me any useful information. I want to bring in my sales or transaction level data. So what I'm going to do is map data, as I showed you earlier, has sales and transactions and units for each row based on city, right? So with that data, what I can do is I can create, right here, I'm creating 2 new columns, and this is in that data frame map locations, our main data frame, and I'm calling them sales and transactions. This is the actual code I'm using. So this creates those columns, and then next to it you see the actual code where I'm taking and pulling the sales data from map data and the transaction data from map data, and I'm putting them in here. Okay, so it's going to be correct. It's going to be lined up exactly based on, you know, every entry in there correctly. Next, what I do is I want to group, I want to differentiate it. I want to be able to see this in colors on here. So the first grouping here is I'm grouping by sales into 3 different colors: blue, orange, and red. I could have picked anything I wanted to. And you can do ranges too, but this way I know beyond a shadow of a doubt, if it's blue, it's under 500,000 in sales. If it's orange, it's under $1 million, and if it's red, it's $1 million plus. Okay, so I could have made it less than or equal to. That's fine. Just for the purpose of this, the first row here is just building up the nested if-else. Okay, this is the exact code in here. It has if-else, the data frame map location sales column, less than 500,000 blue, then you get orange and red. That's exactly how the code works. Then what I do is I copy that and I put it in here into this definition of the column for that. So I'm creating the new column color 1 in this, and it's going to put this in there. Let me show you the whole code here. It's kind of long and lengthy, but this is the actual code. So what makes it long is I'm just copying this first line right here into it right here for the C right here to put that in there. And what it's going to do is it's going to give me the colors for each one. I'll show you this in just a second. The next one down does the same thing. The first row here, we don't run this. This is just building out the nested if. So in this case, I'm building 4 groups based on transaction size. Okay, so I build out this if else. Let me see if I can show you this a little bit better maybe here. Here's the actual code for it, same with the one above. This one's a little bit longer. It's got 3 if else's in it, and then what it does at the end is it says if it's less than this 3, else everything else gets a 4. Same with this one, less than 1.5 million gets orange, everything above that just gets red. I don't need to do another if else for the last condition. I could, but it's kind of redundant. So the same thing, I copy that row right there and I place it right in here. Same thing as the previous one. Okay, and I build a table based on that, and it goes right in here to this df.map locations transactions 1. Now this is where it gets cool. So down below here I have 2 rows, right? One is, if you read this right here, North Carolina is centered with 1 variable color based on sales. Okay, so if I just wanted to show sales coloration based on one, so there's just one variable in here. All it's the size is going to be the same for each dot, but it'll have different colors for the sales based on, you know, blue, orange, and red. I could do that, but let's take it a step further. So in this next one, I've got 2 variables. So I'm doing the same code you see here for the getMap functionality here, which comes from ggplot, okay, and ggmap. I'm sorry, ggmap, and So I've got getmap. Now I use South Carolina here. The reason being is if I use North Carolina too much, Google says, oh, you used it, you've pulled this data too many times today, and they give me an error. If you want to see it, the actual errors right here, you'll see this over query limit. So if you run this over and over and over again, they'll decide, oh, no, you can't do that. You already ran it for North Carolina. So the way around it is just change it. It doesn't matter if it's North Carolina or South Carolina. It just moves the map down a tiny bit because it's just the center and it bases on how the zoom is. So in this case, I've zoomed it up so I see the whole East Coast anyway. So that really doesn't make a difference. It could have said North Carolina would be perfectly correct. It's just I ran into this error because it's over the query limit. So to get around that, all you do is change up the location. I did South Carolina. And then if you look here, so color has the same df.map locations, data frame, column, color 1. But now what I've done is instead of a size equals 3, now I've got size equals the transactions 1 column, which we created back here based on size. And this is it. All you got to do is go through. I know it looks like a lot, but it's really not. You just go through this, run this. Let me show this over here so you can see all of these guys, okay? And that is the code. And all you do is, so you go and start at the beginning right here. You start with installing your packages, make sure you got them, go through your libraries, make sure everything's in there you need, bring in your data, and then just start building it. You filter it down so that you're not doing the whole world, because if you are, this data set you can use different data sets, it depends on your data set, but this data set has over 2100, 2200, at least, might even be more than that, points all over the world with sales data. Well, that's going to take a while to get all these geomap locations built. So even this one by itself still takes probably 3 minutes to 4 minutes to do for the USA. So you could filter it down farther if you wanted to, but for this case we're just filtering it to the USA right here. We build up the 2 data frames. We've got one for locations right here. Then we've got one for the so this one's got your city and state, but this one's got, you're going to have your latitude and longitude, which it needs to be able to plot those. Then we bind them together in this one right here. Then we build the new columns, sales and transactions, based on the data that's already in map data. They could be somewhere else, but we want it from the exact same data frame. So because that way it knows, you know, that Alabama, for instance, this city, Birmingham or whatever it is, has this level of sales and this level of transactions. We don't have to do a whole lot more extrapolation and data wrangling to get that correct. It's already done for us in there, and you could pre-do that anyway if it wasn't. And then once we do that, we build the group into 3 colors and 4 groups for size. The first line here is not run. That's just to show you how I build the nested if. And then I just copy that and put that right in here after the C. See that? It goes right in there. And that's the end of the whole thing. And then just make sure you have the right number of parentheses at the end. Same thing with here. This one's a little bit longer. It's got 1, 2, 3 if else's in it. Okay, and you don't do an if else for the last one for either one. Then you just do the same thing, copy and paste it in here, and then you've got your get map code. Now you can run this one. This one here would just give you all your cities that have sales, but it would only have the one variable sales, and it would only show color differentiation by 3 groups, 3 colors, red, blue, and orange. I wanted more. So I took this one here and I added this for size, for transactions. And what that does, by having 2 variables, you could even have 3 if you wanted to, but to have 2 variables, color and size, is probably best for this. And it starts to show me insights. So if I bring this back, now that we've showed you how to build it, it's going to look ugly for a second. Give it a second. It'll come back. Do. It has to rethink its map here. Hopefully it does in a second here. It's kind of going a little. There we go. All right. It's not as slow as when you're running the geolocations, at least. But here's our map, okay? And see, because of what I've done, you have different sizes, okay, based on transactional data, right? Transaction numbers, or how many times they've come to a store to shop. And then you've also got your sales. So your sales, remember, the lowest is blue, the middle is orange, and the highest is red. So you've got some reds that are big, which means they have both high transaction levels and high sales levels. And then you also got some sales that are smaller. So they have high sales but lower transactions. Maybe they're selling more expensive stuff. That's probably what it is. Same thing with, look at the blues. Got some really small ones, right? And we've got some bigger ones. And same with the oranges. Look at that. You've got some that are small and some that are big. So what you can see there is you can see patterns, and it doesn't have to just be sales. You could do enrollments in our loyalty program and compare enrollments based on color and sales or transactions based on size. And I could have also made these sizes bigger. So let's say I wanted to make a really big difference. Instead of using 1, 2, 3, and 4 for the size variables, I could have used 2, 4, 6, and 8, which would double them. So the 8 would be very big and then make it much more pronounced. But in the end case, what you've got here is a really cool map that you can start to say, to develop insights on and say, oh, I need to dig further on this. What is causing higher sales here with lower transactions? What items? And then you can go dig into that and figure out what those items are. You might decide, here's an area with a lot of different, obviously it's New York City, Philadelphia, Washington, D.C. Apparently Washington, D.C. is hotter than New York City. Why is New York City so low in sales? Maybe we don't have enough locations. Maybe we need to do some more marketing. Maybe it could be anything, okay? But it depends on the data. Well, what's really cool here is you can do this, and you don't have to just use, so this is a South Carolina map. So you can see how South Carolina right here is the exact center. That's what clicking or picking this right here is. This will give you the exact center point of your map, and then the zoom is the level. So I could have zoomed 4, and it would be a bigger map that would go out to Texas and up to Maine and beyond a little bit more. I could have zoomed in more and made it a 10, and then you would probably just see, South Carolina. And what's cool when you zoom in like that, you actually see the streets. So not all of them, but you'll see like main highways and stuff, and then you can actually plot routes, truck routes, crime. I could have plotted crime ratios in here and figured out areas to avoid for a trucking company. This is the possibilities with your data and graphing it and showing geodata like this is just amazing. I could plot vectors of transmission of disease. So if a new flu breaks out that's really bad, or Ebola in Africa, I could go and zoom in and say, okay, here are the cities where there's instances of it, and here's the worst ones, and maybe, oops, it's near an airport. So we can alert things and alert the authorities that we need to take extra measures to stop its progression. You can look at subways, traffic on the highways, and figure out better routes around things. It's just really neat to be able to use this with your data. It's just another great tool, and this is reusable. So what's really cool is I can change up here that Excel sheet that I brought in, and I could bring in any other Excel sheet. I just need to know beforehand that I need, if I'm filtering by country, so this was a full international data set on furniture sales or furniture part sales, but I could filter it down so that it's just the US like I did here. I could filter it down to India, or I could have a data set that's just New York City data. Well, there you go. I just have to go and get a bigger zoom to go into New York and zoom in on New York City. So it's all depend on the data, but I can reuse it very quickly, just make a couple little changes to it. I'll bring it out here again so you can see what I used here as best I can, and there you go. That's the whole data, or the whole code for this. Let me show you. It goes from there up to here. You don't necessarily have this install package, but you just need to have these in and just go through the steps I showed you here, and you'll be creating some really cool maps. And this will auto size on the right just like it did now, and you'll be able to see your points, your plots, everything that you want to see here. And remember, you can mess with this and change the size. Like I told you earlier, you could make this from 1 to 2 to 3 to 4 instead of 2 to 4 to 6 to 8, or 3 to 6 to 9 to 12, whatever you think would work best for you to best show your data. And then you could mess with the colors. I could have added more if else. I could have said, well, what if I want less than 250,000, less than 500,000, less than a million, or whatever it was. I could do as many of these as I want. I could have, instead of 3 color differentiations, I could have 8. I could have, instead of 4 groups for transactions, I could have 10. It doesn't matter. Or 2. Maybe I only want to know 2 things, high, low. It doesn't matter, but I can go and do that, and then I can play with it and start looking for different patterns in there, which is really cool. So you get 2 options here. The first one gives you broken out by color. The second one does it by both color and size, which I think is really cool. Well, thanks for watching. Please take a moment to subscribe and like so you can see all the other great videos I've got coming out. I love to do great things like this, visuals, and trying to get great insights off of data. Sometimes this gives you a chance to look at your data and get something new out of it, even though you looked at it before. And, it's just cool to get these insights and see what you can see from them. So please subscribe, like, and also be sure and check out my channel. I've got a lot of other great videos on there on everything from data analysis, data science, R, RStudio, Alteryx, Excel, all kinds of things to use to get and extract information and great insights from your data. Thanks again, and have a great day.